So section 4.4 is all dealing with triangle congruence proofs, dealing with side, 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 and side angle side type of theorems. So that's what we're going to work on. We're going to practice proving triangles are congruent using those two congruency theorems. So every triangle congruence theorem proof is going to follow the same kind of general theme, or the same general format. We have 3 boxes, and all of these 3 boxes together lead us to the third box, or sorry, the 4th box. So these 3 boxes, let's call them box 1, 2, and 3, they all funnel into box number 4. And here's why. So all of these theorems, so for example, if we have side, 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 then we can prove that the triangles are congruent. So what that means is we need to prove each pair of sides are congruent. So we have in box 1, this would be 1 pair of sides. In box 2, and also in box 3, we have a different pair of sides. And what that allows us to do then is it allows us to prove that the triangles themselves are congruent. So let's say triangle something or other, I don't know its name yet, will be congruent to triangle some other thing. So that's why we're always going to have this 3 boxes kind of flowing into one. So let's begin our first proof. Let's give it a shot. Oh, I forgot about one thing. Sometimes there are things from diagrams or just how these pictures are drawn that we can consider as kind of given information. So when we have 2 triangles that share a side, then we can use that shared side in our proof. So for example, triangle side length AB and BA would be congruent to itself. And then also we have the sort of this bow tie type shape. Whenever we have 2 lines intersect, then we create these vertical angles. So in this case, vertical angles 1 and 2 would be congruent. And that doesn't need to be specifically given to us, but it's sort of one of those pieces from the diagram. It can be assumed given to us. Now we're ready to start some proofs. So first example is we want to prove that these 2 triangles are congruent. First off, let's figure out which triangles we're talking about. So let's name them. Now, as you remember from other videos, naming triangles in order to prove that they're congruent is an important thing. It's important to keep the order correct. So let's take a look at this triangle on the left. Maybe we could start at angle T here. If we follow T and kind of head in the direction of I, end up at C. So we could say triangle TIC. Well, what does angle T, this angle up top here, what does that correspond with? Well, in this other triangle off to the right, that angle is made up of the shared side and also the segment with 1 congruence mark. So the angle that shares 1 congruence mark and fits the shared side is this angle. So we'll begin naming our second triangle with C. In triangle TIC, we follow T towards I, end up at C. In other words, we go down the segment with 1 tick mark and follow the segment with 2 tick marks. In the green triangle, the one off to the right, we're going to follow 1 tick mark, head towards these second congruence tick marks. So triangle C is where we'll start, head toward A, end up at T. Oh, I can't spell apparently. C-A-T. So we want to prove that triangles C-A-T and T-I-C are congruent. How are we going to do that? Well, let's take a look at those congruence marks again. I see I've got 1 pair of segments. Let's call this IC. IC and AT must be congruent because they both have these 2 pairs of congruence marks on them. And likewise, this segment TI is going to be congruent to segment AC. And then finally, just from the way that these 2 triangles are drawn, we've got a shared side up the middle. And so what that means is I've got the green pair of sides, I've got the blue shared side up the middle, and I've got the red pair of shared sides. So we're going to prove that these 2 triangles are congruent using side, side, side. So let's get to it. So first off, remember we were trying to prove that triangle TIC was congruent with triangle CAT. We were given the two green sides are congruent, so that's TI and CA. And then also we have the two red sides are congruent. So we've got what we have given, we have what we're trying to prove. Now let's start filling in our three boxes. In the previous slide, we established that we are going to use the side-side-side congruence theorem for this proof. So we can fill that in as the reason right now. Let's see, if and so in order to prove that these two triangles are congruent, well, first off, we should name them. We wanted to prove that triangle TIC was congruent to triangle CAT. In order to do that, we need to first prove that we've got a pair of sides, another pair of sides, and a final pair of sides that are congruent. The reason we need to do that is in this triangle congruence theorem, we have the if part of the sentence, the hypothesis, and that must be satisfied in order for the then, the conclusion, to be true. So which pair of sides do we have? I know AT is congruent to IC, and the reason that I know that to be true is that's given information. Likewise, the green segment TI and CA are congruent for the same reasons. We've got given information. And then lastly, we need to talk about the shared side. So that shared side is kind of strange. In triangle TIC, I see that the segment is, if we follow the order of the letters, then the segment would be called TC. However, the corresponding segments in triangle CAT would be, instead of TC, it would actually be CT. And that follows from the order of the letters in the names of the triangles. So we have that shared side, and we need to talk about the fact that that shared side gives us congruent segments. So TC is shared by both triangles, and as a result, it must be congruent in both triangles. And the statement that we use is called the reflexive property of equality. And now we're done. Each of our different puzzle pieces has fallen into place. We've proven what it is we're trying to prove, and now we're good to go. Proof number one, done. Let's take a look at this next one. Again, we're dealing with two triangles that we want to prove congruent, so let's name them. So we can call them triangle TON and triangle FUN, as in proof is a ton of fun. All right, so we want to first prove, all right, TF and OU bisect each other. What does that mean? Well, this word bisect. Bisect means cut in half. So TF and OU cut each other in half. In other words, TF refers to that long segment. TF is cut into two equal parts. Similarly, OU is cut into two equal parts. So now we have two pairs of sides. We've got the reds and the blues. We've got side and side. And right now we're missing a piece, right? We could either use side, 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 side angle, side. And so we're missing a piece. But the way that the shape is drawn, we've got these vertical angles. And vertical angles are always congruent. And so therefore, we're going to prove that these two triangles are congruent using the side angle side theorem. So let's get started. So we know what it is we want to prove. We want to prove that triangles TON and FUN are congruent. And we agreed we're going to use the side angle side congruence theorem. So we can talk about a pair of sides that are congruent, a pair of angles that are congruent, and another pair of sides that are congruent in each of those boxes. So let's start with the reds. I know that UN and ON are congruent. Next, the other pair of sides, the blues, those blue sides are congruent. And finally, the angles up the middle, angle TNO and FNU. Well, okay, so why are all of these segments congruent? The red segments, UN and ON, why are they congruent? Well, they're congruent because TF and OU bisect each other. And what that means is, I know that TF bisects OU. Also, OU bisects TF. So, for the red segments to be congruent, which segment is doing the bisecting and which is being bisected? That's an important question. In this case, TF is doing the bisecting and OU is being bisected. The opposite is true for the blue segments, TN and FN. In that case, OU is doing the bisecting and TF is being bisected. Now, the connector reason, you have to ask yourself, what does bisect mean? Well, bisect means cuts in half. And so for each of these reasons, we're going to use the segment bisector definition. And lastly, we need to talk about where those green angles came from. The green angles came from the vertical angles, and always vertical angles are congruent. So we need a box that says, hey, I have vertical angles, and then the box below it can say that they're congruent. So there's the statement, TNO, FNU are vertical angles, and as a result, vertical angles are congruent. So the statement is, if we have vertical angles, then those vertical angles are congruent. Super. We're done. This shape kind of looks similar to the first proof that we dealt with. We've got two triangles and they share a side length. However, the given information is different. We've got these segments, let's call it MA and HT. Those segments are parallel, right? That's what that little arrow means. And parallel lines always give us angles. So these parallel lines are cut by a transversal to give us these two angles. So those two angles are congruent. Now, furthermore, these segments have these congruence tick marks on them. And as a result, MA and HT are also congruent. So they're both congruent and they're also parallel. And then finally, we've got a shared side up the middle, segment AT. And I know those segments are always congruent to themselves. So we can prove that these two triangles are congruent using the side angle side theorem. Right, we've got the green side length, the red angles, and the blue shared sides. So we're dealing with side, angle, side. So let's piece this together. First, we know MA is parallel to HT, and we also know that MA is congruent to HT. All right, so let's talk about those green sides. We know MA and HT are congruent, and that's given information. Next, we want to talk about the two red angles that we had. We had angle MAT and angle HTA. But why is that true? Well, that's true because of this given information, the two parallel lines. So we have to mention that fact. So the fact that MA is parallel to HT, if we have parallel lines, then alternate interior angles are congruent. So I know it's a bit abbreviated, but that reason, right, the connector with the arrow says if parallel lines, then alternate interior angles are congruent. And then finally, we have the blue sides. We have segment AT, and it's a shared segment. And shared segments are always congruent. Now, we're not quite finished with this proof. Yeah, we've proven that the two triangles are congruent, MAT and HTA, but that's not exactly what we're trying to prove. We want to prove that angles M and H are congruent. In other words, we want to prove that these angles are congruent, H and M. Well, in order to do that, we're going to use the CP-CTC. See, once we've established that the two triangles are congruent, then all of the parts of the two triangles are congruent. That's what CP-CTC stands for. Corresponding parts of congruent triangles are also congruent. And so we can say, given the fact that triangle MAT is congruent to HTA, that means angle M must be congruent to angle H. And now we're done with the proof. This last proof is dealing with something similar to what we've seen before, but in a slightly different way. Here we've got a bisector. However, it's not a segment bisector, it's an angle bisector. I see AN bisects angle FAC. Well, here's angle FAC, and AN cuts it in half. And so that means that these angles will be congruent. Furthermore, we've got these congruence marks, and so that means we've got segment FA and segment CA are congruent. And lastly, there's that shared segment, AN. And so it's getting kind of busy in there, but we've got a pair of sides, the blue shared side. We've got a pair of angles that come from the angle bisector, and then the green sides, FA and CA. So we can prove that these two triangles are congruent using side angle side. So let's get to it. So we're given that AN bisects FAC, and that gave us that these two angles were congruent. Use green. We also had the shared segment, and then also these congruence marks tell me that FA and CA are congruent. So in the previous slide, we agreed we were going to use side angle side to prove that the triangles were congruent. So SAS. And we have, let's see, we've got the red sides that we just mentioned. There's the green angles that come from the angle bisector. And lastly, the shared side. Hopefully this stuff is starting to look familiar to you now. So the red sides, that was FA and CA. And from those congruence marks on the drawing, that's just given information for us. The angles, the green angles, let's call them angle FAN and CAN. The fact that those two angles are congruent was established from this given piece of information. Right? AN bisects angle FAC. And what does bisect mean? It means cut in half. So we need that as a statement. And then just like in a previous proof, the reason that we're going to use to make that leap is essentially the definition on a bisector. However, this one is slightly different. In previous proofs, we had the segment bisector definition. Well, we're bisecting an angle this time. So what does it mean to bisect an angle is according to the angle bisector definition. And then that shared side is starting to look familiar to us, hopefully. And then, lastly, let's make sure that we proved what it is we're trying to prove. We wanted to prove that segments FN and NC, in other words, these little segments, are congruent, which we can prove using the CP-CTC. So here we have established that the two triangles themselves are congruent, and so therefore all of their parts will be congruent as well. And we mentioned that before, that's the CP-CTC. Or if you'd rather, the CP-CTC is a conditional statement. If you'd rather say, if the triangles are congruent, then all the parts are congruent. So if the triangles are congruent, then all the corresponding parts are congruent. So the blue statement is a little bit longer. That's why we can use the CP-CTC as an abbreviation of that statement.